G'day team, welcome back to another video, and today we are going to look at the simplex algorithm in linear programming. So basically what this is looking at our simplexes that we've been practicing creating using our constraints, and we're going to find the optimal value of those expressions, and they are found at the vertices of a simplex. Now vertices are corners, so if we're looking at our feasible region, it's corners of our feasible region. So we're going to do an example below. So we're going to find the minimum value of x plus y if x and y are greater than or equal to 0, 2x plus 3y are greater than or equal to 18, and 4x plus 3y is greater than or equal to 24. So we want to create our simplex, and we need to do that by graphing our constraints, and these are linear equations. So we need to find our x-intercept and our y-intercept. So for this first one, 2x plus 3y is equal to 18. That's a 6, 18. What we need to do, we need to find our x-intercept, so that's when y equals 0. So x int when y is 0, so that means 2x is equal to 18 and x is equal to 9. My y-intercept is when x is equal to 0, so 3y is equal to 18, so that means y is equal to 6. All right, so we've got our 2 points that we can now graph that equation with. We're going to do the same thing, but with our second equation here. Now, just really quickly, x is going to be 24 divided by 4, which is 6, and y is going to be 24 divided by 3, which is 8. All right, so now that we've got those points, we're going to put them onto our graph. So I'm going to graph the first one in red, so I need to go through x equals 9 and y equals 6. So y equals 6, x equals 9, and we're going to throw, thank you, graph. All right, just like that, and we need to label this equation. So this is 2x plus 3y equals 18. Swapping colors to graph the other one, x equals 6 and y equals 8. So just a nice straight line through there as well. And we're going to label this equation as well. So 4x plus 3y is equal to 24. Now, our constraints say that we need to be above the line because they're greater than or equal to. So what that means, let me just grab a different color here, orange. Our simplex is everything above our equation. So all of this area up here. All right. So now we want to find our vertices of this simplex. So we're looking for corners of our simplex. So we've got one there where two straight lines meet, one here and one down here. All right, so we need to look at each of these individually. So down here, I've got a little table. So vertex, and then I've got the function I'm trying to maximize, so x plus y. Okay, so my coordinates, this one down here is the coordinate 9, 0. This middle one, 3, 4. And this coordinate up here, all the way up here, is 0 and 8. Now we take our x and y values here. So 9 plus 0 gives me 9. 3 plus 4 gives me 7. And 0 plus 8 gives me 8. So this one here is my minimum. And that's the one we're trying to find. So therefore, x is equal to 3. Y is equal to 4. And that minimizes this scenario. Hopefully this helps a little bit with simplex algorithm problems. Now, in the next video, we'll be combining all of the previous skills to problem solve. See you in the next one.